Hello guys and welcome to Mudassir's Codinghood. This is our episode 2 for the part 1 series of Java the complete tutorial from beginners to intermediate. In this we are going to take an overview of Java. So let's start with it. Why we need to take an overview of Java? As in all other computer languages, the element of Java does not exist in isolation. Rather, they work together to form the language as a whole. However, its interrelatedness can make it difficult to describe one aspect of Java without involving several others. Often, a discussion of one feature implies prior knowledge to another. For this reason, this chapter presents a quick overview of several key features of Java. The material described here will give you a foothold that will allow you to write and understand the simple programs most of the topic discussed and will be examined in greater details in the remaining episodes of this part 1 series. So let's understand what is object oriented programming. The object oriented programming OOP is the core of Java. In fact, all Java programs are to at least some extent object oriented. The OOP is so integral to Java that it is the best to understand its basic principle before you begin to write even the simple Java program. Therefore, this chapter begins with a discussion of theoretical aspects of OOP. What is paradigm? All computer programs consist of two elements, the code and the data. Furthermore, a program can be conceptually organized around its code or around its data. That is, some programs are written around what is happening and others are written around who is being affected. These are the two paradigms that governs how a program is constructed. The first way is called the process-oriented model. This approach characterized a program as a series of linear steps, that is code. The process-oriented model can be thought of as a code acting on data. The procedural language, such as C, employs this model to considerable success. However, as we have mentioned in episode 1, problems with this approach appear as programs grow larger and more complex. To manage increasing complexity, the second approach, called object oriented programming, was conceived. The object oriented programming organizes a program around its program that can be characterized as data controlling access to code. As you will see, by switching the control entity to data, you can achieve several organizational benefits. Now let's know what is abstraction. An essential element of object oriented programming is abstraction. Humans manage complexity through abstraction. For example, people do not think car as a set of tens of thousands of individual parts. They think of it as a well-defined object with its own unique behavior. This abstraction allows people to use a car to drive to the grocery store without being overwhelmed by the complexity of the individual parts. They can be ignored the detail of how the engine works. A powerful way to manage abstraction is through the use of hierarchical classification. This allows you to layer the semantics of complex systems, breaking them into more manageable pieces. From the outside, the car is a single object. Once inside, you will see the car consists of several subsystems, that is, steering brakes, sound systems, seat belts, heating, cellular phones, and so on. In turn, each of these subsystems is made up of more specialized unit. For instance, the sound system might consist of a radio, a CD player, and MP3. The point is that you manage the complexity of your car or any other complex system through the use of hierarchical abstraction. The hierarchical abstraction of complex system can also be applied to computer programs. The data from a traditional process-oriented program can be transformed by the abstraction into its component objects. A sequence of process step can become a collection of messages between these objects. Thus, each of these objects describes its own unique behavior. You can treat this object as concrete entities that respond to messages, tell you to do something. This is the essence of object oriented programming. So, let us talk about the three principles of object oriented programming. All object oriented programming languages provide mechanisms that help you implement the object oriented model. They are encapsulation, inheritance, and polymorphism. Let's take a look at these concepts now. Now, let's know what is encapsulation. Encapsulation is a mechanism that binds together your code and data which it manipulates and keep both safe from outside interference and misuse. One way to think about the encapsulation is as a protective wrapper that prevent the code and the data from being arbitrarily accessed by other codes defined outside the wrapper. Access to this code and the data inside the wrapper is tightly controlled through a well-defined interface. To relate this to a real world, consider the automatic transmission on an automobile. Now let's know what is inheritance. So the inheritance is a process by which one object acquires the properties of another object. This is a very important part because you can reuse the code without writing it several other times. This is important also because it supports the concept of hierarchical classification. As mentioned earlier in this chapter, most knowledge is made manageable by hierarchical classification. For example, a golden retriever is a part of classification dog, which in turn is a part of mammal, which under the larger class animal. Without the use of hierarchies, each object would need to define all of its characteristics explicitly. However, by the use of inheritance, an object need only define those qualities that make it unique within its class. It can inherit its general attribute from its parent. Thus, it is the inheritance mechanism that make it possible for one object to be a specific instance of a more general case. Now let us understand what is polymorphism first. Polymorphism derived from a Greek word meaning many forms. Poly means many, morphism means forms. It is a feature that allows one interface to be used for a general class of actions. The specific action is determined by the exact nature of the situation. Consider a stack. You might have a program that requires three types of stacks. One stack is used for the integer values, other for the floating points, and one for the characters. The algorithm that implements each stack is the same, even though the data is being stored differs. Now you may think how all of these polymorphism, encapsulation, and inheritance work together in forming object-oriented programming. When properly applied, polymorphism, encapsulation, and inheritance combine the combine to produce a programming environment that supports the development of far more robust and scalable program. A well-defined hierarchy, properly encapsulated code, and inheritance will bring you multiple benefits. An encapsulation allows you to migrate your implementation over time without breaking the code. So as we have studied various topics about the OOPS, so let us see the first simple program of Java. So now that the basic object-oriented underpinning of Java has been discussed, let's look at the program. This is our first Java program in which we will be going to print a message "Hello World" on the terminal. So for that, open your Visual Studio Code and install Java JDK. As I have already installed Visual Studio Code in Java JDK, I'm going to write the program. For that, we need to create a new file with the name example.java. After creating the file, as shown in the program, we will first give a comment. Comment will be, this is a Java program. And call this file in the double quotes example.java. After giving the comment, we will be writing the class name. So for that, we will be using the class keyword, and the name of our main class should be similar to the name of the file, that is example. So we will write example. Open and close the curly braces. Between them, we will write our main function. The main function is the function from where your program starts. Most of the program are going to use the main functions. So we will be discussing the main function in this episode. First, we will use public keyword. Public keyword, as the name suggests, is access specifier that makes the method publicly usable. After that, we will use static. In order to understand static, we need to understand object. Static is used to make a method callable without being instantiated. Public, static, and void. Void keyword defines that the method doesn't return any value. For example, if the keyword is integer, it will define that the method is returning an integer value. If it is set as void, then the method is returning nothing. Then we'll write the name of the method, that is main, from where our program is going to be executed. We'll open and close the brackets, and between these brackets, we have to pass a parameter, that is string args, that is arguments. In this args string, this args parameter is an array. We are going to know about this afterwards, but for now we will understand how to print hello world. So we will open and close the curly braces, and between them we will write a print statement, that is system dot out dot println. Again, between these braces, we will going to write the parameter, string parameter, which we want to print, that is hello world. To terminate the statement, we will be giving semicolons at the end of each statement to terminate it. Now this is a program with 0 errors. To save it, as we can see, the file is still unsaved. We will press keys Ctrl and S on the keyboard. Now you can see the file is now saved. To run the program, we will be using terminal. Open the terminal. write Java C. Java C means a Java compiler, which will be compiling your code into a class file. That class file can be run on any device that is not similar to your operating system. It can be any operating system, for example Linux, Mac, etc. This class file is the main file which runs directly. Here, after Java C, we will give the name of a file. That is example. Click tab to autocomplete. Java example.java. Now click enter. It will take a little time to compile. As you can see, after compiling, it has created a example.class file. This example.class file can be run directly using Java interface. So for that we will be writing in terminal Java. And the name of the class file is example. So we'll write example. Sorry, example. Here you can see we have successfully printed hello world on the terminal. So now that we have seen the working of the program, let's discuss what is in it. Compiling of the program. To compile example program, execute compiler Java C, specifying the name of the source file on the command line as shown. The Java C compiler create a file called example.class that contain the bytecode version of the program. As discussed earlier, the Java bytecode is intermediate representation of your program that contains instruction of JVM. Thus, the output of Java C is not code but can be run directly. To actually run the program, you must use the Java application launcher called Java. To do so, pass the class name example as a command line argument as shown here. Now let's take a look on comments. Although example.java is quite a short program, it includes several key features that are common to all the Java program. Let's closely examine each part of the program. The program begins with the following line, which is this is a simple Java program. Call this file example.java. This is a comment. Like most of the programming language, Java let you enter a remark into a program source file. The content of a comment are ignored by the compiler. Instead, a comment describes or explains the operation of the program to anyone who is reading it. In this case, the comment describes the program and reminds you to explain how some part of the Java example.java are working. Of course, in real applications, these comments generally explain how some part of the program works. Java supports three styles of comments. First is multi-line, second single line, and third is documentation. We will be talking about the multi-line and single comments here, and we'll talk about the documentation later. So now let's see what is a main function. This line begins the main method. As comment preceding, it suggests that this is the line at which the program will begin. As a general rule, a Java program begin execution by calling the main. The full meaning of each part of the line cannot be given now, since it involves a detailed understanding of Java approach to encapsulation. However, since most of the example in the first part of this series will use this line of code. Let's take a brief look at each part now. The public keyword is a access modifier, which allows the programmer to control the visibility of the class member. When a class member is preceded by public, then that member may be accessed by the code outside the class in which it is declared. The opposite of public is private, which prevents a member from being used by the code defined outside the class. In this case, main must be declared public, since it must be called by the code outside its class when the program is started. Then comes to the next keyword, that is static. The static keyword allows the main function to be called without having an instantiator, a particular instance of the class. This is necessary since main is a class by the Java virtual machine before any objects are made. The keyword void is simply to tell the compiler that main does not return a value. As you will see, method may also return some values. If it seems a little bit confusing, don't worry. All of these concepts will be discussed in detail in subsequent episodes. As stated, main is the method called when the Java application begins. Keep in mind that Java is case sensitive. Thus, main with capital M is different from main with lowercase. It is most important to understand that the Java compiler will compile the classes that do not contain a main method, but Java has no way to run these classes. So if you had typed main instead of main, I mean, if you have typed a main with uppercase instead of a main with lowercase, the compiler would still compile your program. However, the Java will report an error while running that it can't find main. Now let's see the two control statements. Although we will look closely at the control statement in the next chapters, the two briefly introduced here. First is the if statement and the for loop statement. The if statement is basically much like any other if statement in any other language. It determines the flow of execution based on whether some conditions is true or false. It is the simplest form shown here. The if condition statement here, the condition is a boolean expression. A boolean expression is one that evaluates to either true or false. If condition is true, then statement is executed. If condition is false, then the statement is bypassed. And the loop statements are an important part of nearly any programming language because they provide a way for repeatedly execute some task. Java supplies a powerful assortment of loop constructs. Perhaps the most versatile is that for loop. The simplest form of for loop is shown here. Let's take a look for the program of if statement. So as we have understand what is the if statement and for statement, we are going to write a program for it. For that, we will create a new file with the name ifsample.java. If sample.java. For creating the file, we will create a class name ifsample. In between the braces, write our main function. Now we will declare an integer. For that, int keyword, after that x and y. Here we have declared two variables of integer value x and y. We will initialize a value to x and y, like x is equals to n and y is equals to 20. And then we will perform conditioning using if statement. We will write keyword if. Under this bracket we will be giving the parameters, that is a condition, and if the condition is being satisfied, that is if x is smaller than y, then it will enter the brackets and print and it will print x is less than x is less than y. We will create another if statement, if, and in this we will pass condition if x is equal to y, then print x is equal to y. Let's see which of this condition is satisfied. So to compile this program, we will again write Java C, name of the program, if, press tab for autocomplete, enter. It will take some time to compile. Sorry, we have to also save this file. Sorry. After saving, again run this same thing, Java C. The program is now successfully compiled. Write Java and the name of the file, the name of the class file, if sample. Click enter. So here it shows x is less than y, and skip the statement x is equal to y, which means if statement is working properly. Now that we have seen the if statement, let's proceed further for the program of for statement. As we have successfully run our if statement program, for statement we will create another file with the name for test for Java. And in this main method, we will write int x, defining our integer value x, and start our for loop, that is for keyword, and between these brackets we will give our parameters, that is x is equals to 0, and the x will run 10 times, and x will increment each time. And after this we will write system dot out dot println. We want to print the number from 0 to 9, so we will be writing this is x base integer x. For saving the file as C for tab test in Java for here we have to define array args. The program is giving an error. After correcting the error, do the same procedure again. Compile it again. After compiling the program, run the program using the Java interface again. You will see the output. We can now print number from 0 to 9. Using blocks of codes. Java allows two or more statements to be grouped into blocks of code, also called code blocks. This is done by enclosing the statements between opening and closing curly braces. Once a block of code has been created, it becomes a logical unit that can be used at any place. That a single state for a single statement. We will see example of block codes for if and for loops. Now, to understand the blocks of code or the code block, let's look at an example for loop statement. The following program uses a block of code as target of a loop. We will create a new file with the name block test. Create a new file with the name block test.java. Name of our class will be block test. We will write our main function public static void main. String AR arguments. Open and close a curly braces. In this, we will declare two variables, integer x and integer y. Y is equals to 20. After initializing y, we will open for loop for x is equals to 0 and x will iterate till n. X plus plus, which means s will increment each time. After each iteration, x will increment. We will open the block of code. This is the starting of a block. This the end of block. Within this block, we can write n number of statements. So we will be writing two statements to print we will initialize y is equals to y minus 2 and terminate the statement by putting a semicolon in the end. And within these two statements, first we will print the value of x. And here we will printing the value of y. After saving the file, by pressing Ctrl S, write Java C Java C block test. Press tab. Here the spelling of system is incorrect. After again saving the file, compile your program. successfully compiled, and you can see block test.class here. Now write Java block test. Here you can see two statements, this is x and this is y, are running simultaneously. So using a block of code, you can run number of statements between these blocks. Lexical issues. Now that you have seen several short Java programs, it is the time for more formally describes the atomic elements of Java. Java programs are a collection of white spaces, identifiers, and literals, comments, operators, separators, and keywords. The operators are described in the next episodes. The others are described next. So let's know what is white space. Java is a free-form language. This means that you don't need to follow any special indentation rule. For instance, the example program could have been written all on one line or in any other strange way you felt like typing it, as long as there was at least one white space character between each token that was not already delineated by an operator or separator. In Java, white spaces include a space, tab, new line, or form field. Now let's understand what are identifiers. Identifiers are used to name things such as classes, variables, and methods. An identifier may be any descriptive sequence of uppercase and lowercase letters, numbers, or the underscores. They must not begin with any number, lest they be confused with the numerical literals. Again, Java is a case sensitive language, so an identifier named value with uppercase is different than an identifier named value with lowercase letter. Separators. In Java, there are few characters that are used as the separators. The most commonly used separator in Java is the semicolon. As you have seen, it is often used to terminate statements. The separators are shown in the tables. The first separator here is parenthesis. It is used to contain the list of parameters in the method definition and invocation. Also used for definition of precedence in expression, containing expression in controlling statement, and surrounding the cast types. The second symbol is parenthesis, braces. Sorry, it is called as braces, used to contain the value of automatically initialized array. Also used to define a block of code for classes, methods, and local scopes. The third is called as square brackets, which are used to declare array types. The fourth is semicolon. It is used to terminate the statements. The fifth is comma. The comma is used to separate the consecutive identifier in a variable declaration, also used to chain statement together inside a for loop. The sixth is period. It is used to separate package names from the subpackage and the classes, also used to separate a variable or methods from a reference variable. Now let's have a look at Java keywords. There are 61 keywords currently defined in Java language. These keywords, combined with the syntax of operators and separators, form the foundation of Java language. In general, These keywords cannot be used as identifiers, meaning that they cannot be used as a name of a variable, class, or method. The exception to this rule are the context sensitive text or keywords added by JDK 9 to support modules. Thank you for watching. I hope you liked the video. Don't forget to like, comment, and share this video, and wait for episode 3. Thank you so much.